for a place to set up the antenna, and I don't know exactly where I am, but it looks like a little country road. I might stop around here actually, this doesn't look too bad. I might do a U-turn here. And just trying to avoid, too many power lines and other sources of electrical interference. But I think here looks pretty good. I'll just I need to find a little place to pull over to the side of the road where I'm not in the way. Okay, so here we are. We've got the antenna set up. I haven't got it at full height, but I think it's high enough. There's nothing really around it to interfere with it. The actual antenna is just that little white bit that you see up the top. You can see the connector going into the bottom of it. Now in there's some electronics, of course, and what it does is it amplifies the tiny little signals and sends them down that cable, which you can see running along the ground here, along here. Got a lot more cable than what I need, of course. From here it goes into a power injector. Basically it lets the radio signals travel through onto the sound card, and at the same time it allows me to apply 12 volts up that same cable, let the radio signals come down and up and power the device up the top of the pole. There's a sound card there, and it's a Steinberg UR12, samples at 192 kilohertz with fairly good quality op amps inside. It's a power supply there that powers 12 volts into the injector, which feeds the antenna, and sound card's connected via USB to the laptop. Now I don't know if we can see it or not, but there's millions of flies around here. They're really starting to do my head in, so I might have to spray something on myself to keep them away. As I said last night, it rained pretty much all night, and you can see the water still running off from everywhere around. Pretty much all this part of New South Wales, just great big puddles of water everywhere, so it must have rained a fair bit. Okay, here we are. I've set the software to record, so it's recording the spectrum from DC to 192 kilohertz. Well, actually, I should say about 80 kilohertz, because 192 kilohertz sound card can only, you're only going to be seeing about 80 or 90 kilohertz, about half. So it's recording the spectrum at the moment. The signals are pretty much the same as what I'm used to seeing in Melbourne at home, surprisingly. Although the levels are a lot higher, the signal to noise ratio is a lot higher, but there's some sort of interfering signal. You can see the whole spectrum raising and lowering all the time, and as you can see, when it raises, it actually completely swamps the signals at some points. So the signals are only there when the spectrum drops. So I don't know what's causing that, but I'm just assuming that there's some machinery or something like that is being used on one of the farms around here, and it's causing a bit of interference through the power grid. And that's the only thing I can put it down to. There's a lot of crackling as well in the background, which is just your standard lightning in the distance, and that these long lines that go right across the screen generally are the result of lightning strikes. Lightning strikes produce a broadband kind of noise, so that's why you get that. It covers the whole frequency range. You can see them clearly there. There's horizontal lines. A typical radio signal at these frequencies is just a line going downwards, as you see these three lines here, and there's other lines there, and at the moment can't really see them. The beauty of it is that the actual software, can't really try to get rid of the glow. The software is actually recording everything to the laptop, and I can then go back at a later date and go through and very, very finely check all these signals out. Like for example, I can zoom in now, but I can also zoom in after the fact. Let's just zoom into that. So you can see now, you can see the actual shape of the signals, and you can see the data in there. This particular signal here, I'll just set the info on it, is 19.79 or 19.8, which is a VLF transmitter in Exmouth. I think it's Exmouth in Western Australia. It's an old, well, it's an army or navy base or whatever, and it basically sends information to submarines under the water, under the sea. And that white stuff that you see there is basically the data that's being sent. The way they send the data is they shift the frequency for a high and a low, and at the other end the receiver receives that and decodes it and then unencrypts it, because the information being sent is encrypted at all times. So even though you could physically look at that data and actually get some software to actually spit out what you're seeing there, as in letters and numbers, it'll be all encrypted anyway, so you wouldn't be able to, decipher anything about it. As you can see at the moment, we've got peaks at minus 42 dB, which is quite strong. The noise floor is at minus 73. Oddly enough, at home in Melbourne, the noise floor is often around about minus 90, so the noise floor here is a lot higher for some reason. Mind you, this is a slightly different antenna than what I use at home, so not sure where that's going to do it. The signal to noise ratio of this particular signal is 33 dB, so it's actually 33 dB above the noise, which is quite incredible, or quite amazing. I think the highest I've seen that in Melbourne has been around about the 20 to 22 dB above the noise floor, so we've got a whole 10 plus dB more here than what I have in Melbourne. At the moment we're just zoomed into a part of the spectrum there, 17.5 kilohertz to 21.5 kilohertz, and you can see three main signals in there. All of those are the same type of signal, basically designed to communicate with submarines under the ocean anywhere in the world. And in between those, or actually below the noise floor, you can see quite a few other smaller signals, but they only show up when the noise floor drops. See that? See, when the noise floor drops down to here, you can actually see other signals in there. There's quite a lot of them. Now, I do get some of those in Melbourne, but there's a lot of those that I do not get in Melbourne. So it's a shame that the noise floor's so high and I can't actually see them clearly. But yeah, I'm actually staying in Merimbula. This is about 20 kilometres from Merimbula. Tonight I'm going to try and set this same antenna up where I'm staying, and I'll try and do some observations at 1 o'clock in the morning, when generally machinery and all that is not working. You tend to get a much better result. So I'll try to do some observations tonight. Yeah, at the moment the software is actually recording. I've had it on record for a little while now. I'll just see how big the file is so far. Where are we? Okay, we've so far 330 megabytes. I'll just let that continue on recording until I've got about at least a gigabyte. I'll save that, and then beauty of that is I can, at the moment this is live, but the beauty of the recording function is that I can then come back, play the recorded file through the same software, and I can still zoom around and analyze and look at signals exactly the same as I did as I'm doing right now. And because everything's time stamped with dates and times and that, you can basically review what you received at any time. The flies are starting to do my head in a bit, but anyway. Alright, I wish that interference would stop, because it's really knocking my my weaker signals around dramatically. I mean, there's a spot there between 20 and 21 kilohertz where you can see quite a lot of weaker signals, but you can only see them when the noise floor drops. See, they just showed up then. So basically the signals are there, but the noise floor at the moment is higher than the signals, so you can only see the signals when the noise floor drops. The fact that the noise floor is bouncing up and down the way it is generally indicates that it's not a natural thing. It's more like some sort of man-made noise. So I'm guessing some kind of machinery that's having on and off cycles, and of course any interference from machinery will transfer straight through to the power lines, and then the power lines radiate that, and of course this antenna will receive that.